Hello, in this lecture we'll find out the value of angle theta. In the drawing we have triangle ABC. Triangle ABC is an isosceles triangle, that is to say CB equals to CA. In addition, we know that this angle equals to 20 degrees, and it is also given us in the question that angle NAB equals to 50 degrees in its size, and this angle MBA equals to 60 degrees in its size. Repeat again, it is given us the question that angle ACB equals to 20 degrees in its size, angle NAB equals to 50 degrees, and angle MBA equals to 60 degrees in its size. Our mission is to find out the size of this angle theta, that is actually angle NMB. So first of all, we focus on the isosceles triangle ABC. So we copy triangle ABC in a new page, and we'll analyze this triangle ABC. Angle ACB equals to 20 degrees. So actually, this is triangle ABC that I call it from the original drawing. AC equals to BC. The triangle ABC is an isosceles triangle, and we have that all that in front of equal sides in the triangle are equal angles. So those two angles that are located in front, those two equal sides must be equal to each other. So if one angle is theta, then the other angle must be also equal to theta. According to the rule that the sum of the angles in any triangle is equal to 180 degrees, in triangle ABC we get that theta plus theta is 2 theta plus 20 degrees equals to 180 degrees. We subtract 20 degrees from this equation, and finally we get that 2 theta equals to 180 minus 160 is 180 minus 20 is 160, so 2 theta equals to 160 degrees. We divide this equation by 2, and finally we get that angle theta equals to 160 over 2, it is 80 degrees. So this angle theta equals to 80 degrees in its size, and this angle theta also equals to 80 degrees in its size. So in the original drawing, we have this angle theta that is equal to 80 degrees, because of the fact that this angle equals to 50 degrees. Therefore, the missing angle must be equal to 30 degrees. In order to complete the size of angle theta to 80 degrees, the missing angle here must be equal to 30 degrees. Likewise, this is also angle theta, but angle MBA equals to 60 degrees. So the missing angle must be equal to 20 degrees. In order to complete the size of angle theta to 80 degrees, the missing angle must be equal to 20 degrees. In the next step, I'll copy triangle NAB in a new page, and we'll analyze this triangle NAB. So This is angle theta that is equal to 80 degrees in its size. This is angle NAB that is equal to 50 degrees in its size. Actually, this is triangle NAB that I copied from the original drawing. We define the missing angle as theta. The sum of the angles in triangle A and B must be equal to 180 degrees, that is to say 50 degrees plus 80 degrees plus angle theta. In total, they must be equal to 180 degrees. 50 degrees plus 80 degrees is 130 degrees, so we subtract 130 degrees from this equation, and finally we get that angle theta equals to 180 degrees minus 130 degrees, it is 50 degrees. So this angle theta equals to 50 degrees in its size. Angle A and B equals to 50 degrees in its size. So in this triangle A and B, those two angles, they are equal to each other. Each of them equals to 50 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, they are equal sides. So those two sides that are located in front the equal angles must be equal to each other. That is to say, side AB equals to side NB. AB equals to NB. AB equals to NB. So here, write down the original drawing that side AB equals to side NB. Okay. In the next step, we'll focus on triangle A and B. This triangle A and B. So I will copy triangle A and B in your page, and we'll analyze this triangle A and B. Angle MBA equals to 60 degrees. This is actually angle theta that we calculated in the beginning of the lecture, that is equal to 80 degrees. So actually, this is triangle A and B that are copied from the original drawing. We define the missing angle as theta. The sum of the angles in triangle A and B must be equal to 180 degrees. That is to say, 80 degrees plus 60 degrees plus the missing angle that is theta must be equal in total to 180 degrees. 80 degrees plus 60 degrees, it is 140 degrees, so we subtract 140 degrees from this equation, and we get that angle theta equals to 180 degrees minus 140 degrees, it is 40 degrees. So the missing angle theta, that is actually angle A and B, equals to 40 degrees in its size. Angle A and B equals to 40 degrees in its size. Angle A and B equals to 40 degrees. Okay. In the next step, we create line segment BD. From point B, we draw straight line on CA in such a way that BD will be equal to BA. Okay, so this is line segment BD, and we build line segment BD in such a way that BD will be equal to AB. So here BD equals to AB according to our construction. I write it down. BD equals to AB according to our construction. Okay. So in the next step, we focus on triangle ADB. So I copy triangle ADB in the new page and we analyze this triangle, triangle ADB. So actually, this is triangle ADB that I copied from the original drawing. Angle DAB equals to 80 degrees. This is the angle that we calculated at the beginning of the lecture. According to our construction, AB equals to DB. Those two sides are equal to each other. Again, we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front, the equal sides must be equal to each other. But this angle equals to 80 degrees, therefore the missing angle must be also equal to 80 degrees in its size. Okay, so here, angle ADB equals to 80 degrees. Angle ADB equals to 80 degrees in its size. We continue to focus on triangle ADB. The sum of the angles in triangle ADB equals to 180 degrees. We define the missing angle as theta. So 80 degrees plus 80 degrees plus theta, in total they must be equal to 180 degrees. 80 plus 80 is 160, so we subtract 160 degrees from this equation, and finally we get that angle theta equals to 180 minus 160 is 20 degrees. The missing angle is equal to 20 degrees, that is to say angle ABD equals to 20 degrees in its size. This is angle ABD that is equal to 20 degrees in its size. So here we have the big angle, angle ABM equals to 60 degrees in its size. The small angle, ABD equals to 20 degrees in size. Therefore, the missing angle, DMB, will be equal to the big angle ABM minus the small angle ABD. I write it down. The missing angle, DBM, equals to the big angle that is actually angle ABM minus the small angle that is actually angle ABD. So the missing angle, DBM, equals to the big angle ABM that is equal to 60 degrees minus the small angle, ABD that is equal to 20 degrees. So the missing angle DBM equals to 60 degrees minus 20 degrees, it is 40 degrees. DBM equals to 40 degrees in its size, so I write it down in the original drawing that DBM equals to 40 degrees in its size. Okay. In the next step, we will join points D and N together by a straight line. we will focus on the green triangle DNB. The green triangle DNB. So I'll copy the green triangle DNB. In the new page we will analyze it. Angle DBN, this angle equals to 40 degrees plus 20 degrees, that is 60 degrees. And we have already found out that DB equals to NB. Okay. DB equals to NB. Because of the fact that AB equals to NB, those two sides are equal to each other, and we built again AB equals to ND, because those two angles in triangle A and B, they are equal to each other. Therefore, in front of equal angles, they are equal sides. That is to say, those two sides are equal to each other from one side, but from the other side, according to our construction, DB equals to AB. Here, DB equals to AB, and therefore we found out that in conclusion, DB equals to NB. Okay. DB equals to NB. DB equals to NB. In triangle DNB, those two sides again DB equals to NB. This is DB and this is NB. In front of those two sides are equal to each other, we have those two angles. According to the rule that in front of equal sides there are equal angles, those two angles must be equal to each other. So if one angle is theta, then the other angle must be also equal to theta. In triangle DNB, the sum of the angles must be equal to 180 degrees. So theta plus theta is 2 theta plus 60 degrees. In total, it must be equal to 180 degrees. We will subtract 60 degrees from this equation, and we will get that 2 theta equals to 180 minus 60, this is 120. So 2 theta equals to 120 degrees. We will divide this equation by 2, and we will get finally that theta equals to 60 degrees in its size. So this angle theta equals to 60 degrees, and this angle theta also equals to 60 degrees in its size. Because of the fact that in triangle DNB we have three angles that are all equals to 60 degrees in its size, we will derive from it that triangle DNB is an equilateral triangle. In any equilateral triangle, all the sides are equal to each other, of course. So in triangle DNB, side DB equals to side NB equals to side DN. Okay, this is from one side, and from the other side we found out that AB equals to NB, AB equals to NB, again all the sides of the quadrilateral triangle, the green triangle, are equal to each other. That is to say DB equals to NB equals to DN. Okay, now we focus on this side of the straight line CA at point D. In the equilateral triangle DNB, this angle of course equals to 60 degrees. So on the straight line CA, on this side of the straight line CA at point D, we have this angle that is equal to 80 degrees. This angle equals to 60 degrees. Repeat again. On this side of the straight line CA at point D, this angle equals to 80 degrees. This angle equals to 60 degrees. Therefore, the missing angle on 80 plus 60 is 140. Therefore, the missing angle must be equal to 40 degrees, because 140 plus 40, it is 180 degrees. It is the sum of the angles on one side of the straight line. So this angle equals to 40 degrees. Yeah, this angle CDN equals to 40 degrees in its size. And we have already found out that DB equals to NB equals to DN, AB equals to NB, and we also found out that so here we have in triangle DMB, we focus on triangle DMB. So I copy triangle DMB in a new page and we will analyze triangle DMB. Okay. In triangle DMP, angle MBD equals to 40 degrees in its size. Angle DMB also equals to 40 degrees in its size. Okay. So this is triangle DMB, this is the copy from the original drawing. And we have the rule that those two angles are equal to each other. Okay. And we have the rule that in front of equal angles in the triangle there are equal sides. So DM must be equal to dB. DM equals to dB. DM equals to dB. And we've already found out that dB equals to NB equals to dN. So dB actually dm from one side, dm equals to dB. Okay, dm equals to dB. And from the other side, dB equals to dn. Yeah, dB equals to dn. dB equals to dn. So from this equation, we will derive that dm equals to dn. dm equals to dn. dm equals to dn. The next step, I will copy triangle DMN in a new page and we'll analyze it. Again, dm equals to dn. Yeah, dm equals to dn. And we already found out that angle MDN, this angle equals to 40 degrees. Angle MDN equals to 40 degrees in its size. So dm equals to dn. And we have the rule, the same rule, that in front of equal sides there are equal angles. So in front of those two sides, we have those two angles. Therefore, those two angles must be equal to each other. If this angle is theta, this angle must be also equal to theta. And the sum of the angles in triangle DMN must be equal to 180 degrees. Theta plus theta is 2 theta, plus 40 degrees must be equal to 180 degrees. We will subtract 40 degrees from this equation, and we get that 2 theta equals to 180 minus 40 is 140, degrees. We divide this equation by 2 and we finally found out that angle theta equals to 140 degrees over 2, it is 70 degrees. So the size of angle theta is equal to 70 degrees. This angle theta equals to 70 degrees in size, and this angle theta equals to 70 degrees in its size. So angle DMN, this is angle DMN, that is equal to 70 degrees in its size. This angle DMN, the big angle DMN, equals to 70 degrees in its size. Angle DMB, the small angle DMB, equals to 40 degrees. The small angle DMB equals to 40 degrees in its size. So if you subtract the two angles from each other, the big angle DMN minus the small angle DMB will give us the missing angle, angle theta, that is the angle that we are looking for. The big angle DMN minus the small angle DMB equals to angle theta, that is actually angle NMB, that is the angle that we are looking for. So the big angle is equal to 70 degrees minus the small angle, that is 40 degrees. 40 degrees minus 70 degrees minus 40 degrees, it is 30 degrees. 70 degrees minus 40 degrees, it is 30 degrees. So we found out that the missing angle theta, that is the angle that we are looking for, is equal to 30 degrees in its size. Angle theta, that is angle NMB, equals to 30 degrees in its size. In the next step, we'll summarize the lecture. So in this lecture, we found out the size of this angle theta, that is actually angle NMB. It is given as the equation that triangle ABC is an isosceles triangle, that is to say AC equals to CB. In addition, we know that this angle ACB equals to 20 degrees in size. This angle NAB equals to 50 degrees in size, and this angle MBA equals to 60 degrees in size. Our mission is to find out the value of this angle theta, that is actually angle NMB. So first of all, we focused on triangle ABC. So I call it triangle ABC in a new page and analyze this triangle ABC. It is given as the equation that AC equals to CB, this angle equals to 20 degrees. And we have the rule that in front of equal sides in the triangle, there are equal angles. So in front of those two equal sides, we have those two angles that must be equal to each other. So if one angle is theta, then the other angle must be also equal to theta. And the sum of the angles in triangle ABC must be equal to 180 degrees. So theta plus theta is 2 theta plus 20 degrees. In total, they must be equal to 180 degrees. If we subtract 20 degrees from this equation, we found out that 2 theta equals to 180 minus 20 is 160. 2 theta equals to 160 degrees. We divided this equation by 2 and finally found out that angle theta equals to 160 degrees over 2 is 80 degrees. So angle theta equals to 80 degrees in its size. Each angle here, theta equals to 80 degrees. So this angle theta in total must be equal to 80 degrees. But this angle also equals to 50 degrees, so the missing angle must be equal to 40 degrees in order to complete the sum, the size of angle theta to 80 degrees. The missing angle must be equal to 30 degrees. Likewise, this is angle theta that is equal to 80 degrees, but this angle it is already equal to 60 degrees, so the missing angle must be equal to 30 degrees in order to complete the size of angle theta to 80 degrees. The missing angle must be equal to 20 degrees. Then we focus on triangle A and B. So I copy triangle A and B in a new page and analyze this triangle AB. Angle NAB equals to 50 degrees, and this is angle theta that is equal to 80 degrees. So the missing angle, we define the missing angle as theta. In triangle A and B, the sum of the angles must be equal to 180 degrees. So 50 degrees plus 80 degrees plus theta, total must be equal to 180 degrees. 50 degrees plus 80 degrees, it is 130 degrees. So we subtracted 130 degrees from this equation, and finally found out that angle theta equals to 180 degrees minus 130 degrees, it is 50 degrees. So this angle equals to 50 degrees in its size. Angle A and B equals to 50 degrees in its size. In this triangle A and B, we have those two angles that are equal to each other, and we have the rule that in front of equal angles in the triangle, they are equal sides. That is to say, those two sides that are located in front, the equal angles must be equal to each other. That is to say, AB equals to NB. AB equals to NB. Here you can write down that AB equals to NB. Then we focus on triangle A and B. This is triangle A and B. So I copy triangle A and B in a new page and we analyze it. This is triangle A and B that I copied from the original drawing. Angle ABM equals to 60 degrees. This is angle theta that we calculated in the beginning of the lecture that is equal to 80 degrees. Okay. This angle equals to 60 degrees. Angle MAB equals to 80 degrees. And this is the missing angle that we defined as theta. In triangle A and B, the sum of the angles must be equal to 180 degrees. That is to say, 80 degrees plus 60 degrees plus angle theta, in total they must be equal to 180 degrees. 80 degrees plus 60 degrees, it is 140 degrees, therefore we subtracted 140 degrees from this equation. And we got that angle theta equals to 180 minus 140, it is 40 degrees. So angle A and B, that is angle theta, equals to 40 degrees. This is angle A and B, that is equal to 40 degrees in its size. Then we focused on triangle. Actually, we did the construction here. From point B, we draw line segment BD in such a way that line segment BD will be equal to AB. Again, BD equals to AB according to our construction. Okay, according to our construction, BD equals to AB. BD equals to AB. So in triangle ADB, this angle equals to 80 degrees. This angle equals to 80 degrees, and because of the fact that AB equals to DB, we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But this angle equals to 80 degrees, therefore the missing angle must be also equal to 80 degrees. So angle ADB equals to 80 degrees in its size. We continue to focus on triangle ADB. On triangle ADB, the sum of the angles must be equal to 180 degrees. That is to say, 80 degrees plus 80 degrees plus the missing angle that we defined as theta. In total, they must be equal to 180 degrees. 80 degrees plus 80 degrees, it is 160 degrees plus theta. In total, they must be equal to 180 degrees. We subtracted 160 degrees from this equation and finally found out that 180 minus 160 is 20. So angle theta, that is angle ABD, equals to 20 degrees in its size. This angle ABD equals to 20 degrees in its size. The small angle ABD equals to 20 degrees in its size. The big angle ABM equals to 60 degrees in its size. Therefore, the missing angle, that is angle DBM, must be equal to the big angle ABM minus the small angle ABD. Repeat again, the missing angle AB and DBM must be equal to the big angle ABM minus the small angle ABD. The big angle ABM equals to 60 degrees in size. The small angle ABD equals to 20 degrees. Again, the big angle ABM equals to 60 degrees, the small angle ABD equals to 20 degrees. Therefore, the missing angle DBM equals to 60 minus 20, that is 40 degrees. The missing angle DBM equals to 40 degrees in its size. Then, actually, we join points D and N together by a straight line. In this way, create a triangle DNB. In this triangle DNB, know that DB equals to NB. Then DB equals to NB. Repeat again, AB equals to DB according to our construction. We build DB in such a way that DB will be equal to AB. Okay, and then we found out that DB equals to NB equals to, because of the fact that AB equals to NB, I found out that DB equals to NB. AB equals to DB according to our construction, and here DB equals to NB because of the fact that we have the triangle those two angles, they are equal to each other, they are both equal to 50 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, there are equal sides. That is to say, AB equals to NB. Okay? AB equals to NB. From one side, AB equals to NB. But from the other side, DB also equals to AB. Okay, again, from one side, AB equals to NB. From the other side, according to our construction, AB also equals to DB. Okay, and from those two equations, again, AB equals to NB from one side, from the other side, AB equals to DB. And from this equation, we derive that DB equals to NB. DB equals to NB. If DB equals to NB. Okay. Repeat again, DB equals to NB. So, in the red triangle NDB, this angle ABD equals to 40 plus 20, that is 60. This angle equals to 60 degrees, and we know that DB equals to DN. DB equals to DN, and we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front the equal sides must be equal to each other. So if one angle is theta, then the other angle must be equal to theta. And the sum of the angles in triangle DNB must be equal to 180 degrees. So theta plus theta is 2 theta plus 60 degrees must be equal to 180 degrees. Okay. So we subtracted 60 degrees from this equation. We found out that 2 theta equals to 180 minus 60 is 120. So 2 theta equals to 120 degrees. We divided this equation by 2 and finally we found out that angle theta equals to 120 over 2, that is 60 degrees. So this angle theta equals to 60 degrees, this angle theta equals to 60 degrees. And because of the fact that all the angles inside triangle DNB are equal to 60 degrees, it means the triangle DNB is an equilateral triangle. And we know that in any equilateral triangle, all the sides are equal to each other, of course, so dB equals to Bn equals to Dn. dB equals to Nb equals to Dn. And then we focused on this side of the straight line CA at point D. Focus on this side of the straight line CA at point D. Okay. On this side of the line CA at point D, where this angle is equal to 80 degrees. This angle equals to 60 degrees because it is one out of the three angles of the equilateral triangle and DB. Okay, again, this angle equals to 80 degrees, this angle equals to 60 degrees. 80 plus 60 is 140. Therefore, the missing angle must be equal to 40 degrees according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. The sum of the angles on this side of the straight line CA at point D must be equal to 180 degrees. 140 plus 40 is 180. So this angle equals to 40 degrees. This is actually angle MDB, MDN, that is equal to 40 degrees. Then we focused on triangle DMB. On triangle DMB, so I copied triangle DMB in the new page and we analyzed it. This is triangle DMB that I copied from the original drawing. Angle DBM equals to 40 degrees in its size, and angle DMB also equals to 40 degrees in its size. Okay, so those two angles, they are equal to each other. Again, we have the rule that in front of equal angles in the triangle, there are equal sides. So those two sides that are located in front of equal angles must be equal to each other. That is to say, dm equals to db. Okay, dm equals to db. Here, dm equals to db. Those two sides are equal to each other. Okay, and we have already found out that db equals to nb equals to dn. Here, db equals to nb equals to dn. So from one side, db equals to dm. From one side, db equals to dm. But from the other side, db also equals to dn. Here db equals to dn. So from one side db equals to dm, and from the other side db equals to dn. And from this equation we will derive that dm equals to dn. dm equals to dn. Here dm equals to dn. In the next step, I copied triangle DMN in a new page and we analyze this triangle, triangle DMN. This is triangle DMN that I copied from the original drawing. Angle MDN equals to 40 degrees, and those two sides are equal to each other. That is to say, DM equals to DN. Okay, DM equals to DN. And where the rule that in front of equal sides in the triangle there are equal angles. So those two sides are located in front of those two angles, and therefore those two angles must be also equal to each other. So if one angle is theta, then the other angle must be also equal to theta. The sum of the angles in triangle DMN must be equal to 180 degrees. That is to say, theta plus theta is 2 theta plus 40 degrees. In total, they must be equal to 180 degrees. We subtracted 40 degrees from this equation, and finally we found out that 2 theta equals to 180 minus 40, it is 140. So 2 theta equals to 140 degrees. We divided this equation by 2, and finally we found out that angle theta equals to 70 degrees in its size. Angle theta is angle DMN that is equal to 70 degrees. So the big angle is angle DMN. This is angle DMN that is equal to 70 degrees. The small angle is DMB that is equal to 40 degrees. So the big angle DMN minus the small angle DMB must be equal to angle theta, that is the angle that we are looking for. Again, the big angle DMN minus the small angle DMB must be equal to the missing angle theta, that is actually angle NMB. The big angle equals to 70 degrees, the small angle equals to 40 degrees, so 70 minus 40 is 30 degrees. So actually we found out finally that the size of this angle theta, that is actually also angle NMB, equals to 30 degrees in its size. Okay, thank you very much.